Video.
Living in Britain, we probably think the Earth's firm and solid. But is it? What about volcanoes? They can be catastrophic. And then there are earthquakes too.
The epicenter was 100 miles out to sea, but the whole northern part of Japan was shaken. Smaller shocks have continued throughout the day.
Events like these suggest the Earth is not as stable as we think it is. Scientists have always been keen to understand more about volcanoes and earthquakes. They want to explain what is going on in the ground beneath us. They've carried out investigations all over the world. From their investigations, they've noticed a pattern. The position of earthquakes and volcanoes all seem to be grouped together in a pattern of lines around the world. This just added to another global pattern that they'd known about for a long time. From early maps like this, it was noticed that the shape of the coastlines down either side of the Atlantic was similar, and that Africa and South America would fit together like a jigsaw. Was there a link between this and the pattern of earthquakes and volcanoes? Some scientists had the idea that the continents were once joined together and had since drifted apart, and that earthquakes and volcanoes had something to do with it. It was an idea that few people were keen to believe, so the scientists set out to collect evidence by matching rock types on both sides of the Atlantic. These are areas they found older than 2,500 million years, and these are areas of rock formed between 2,500 and 600 million years ago. And they also found rocks less than 140 million years old, containing similar fossils. This suggested that South America and Africa were once part of the same landmass and have since been pushed apart. Other continents have been moved about too. In some places, they had collided, creating massive mountain ranges like the Himalayas and the Alps. Here in the Alps, scientists found evidence for these collisions. These small folds in the rocks in a gorge in Italy are an example. The model shows how these folds have been formed. The scientists found similar folds in larger areas too, folds occupying whole hillsides. The same evidence was discovered in other mountain ranges, confirming their idea that the continents had moved. It's taken millions of years for the continents to move into the position they're in today. And they've not only been drifting apart or bumping into each other. In some places, land masses have been sliding past each other. The effects of that have been felt in more recent times. In 1906, in San Francisco, the Earth jerked. Buildings toppled, ships were stranded, trains fell over. In the chaos, fire broke out and the city was totally destroyed. This was caused by the famous San Andreas Fault. It's a long tear in the ground running for about 1,000 kilometers. The San Andreas Fault is on the west coast of North America in California, and it runs through San Francisco and Los Angeles. The land masses on either side of the fault are sliding in opposite directions. You can see how movement along either side of the fault, the straight line, has bent the course of this river, which originally flowed straight across it. The San Andreas fault line is part of the global pattern of earthquakes and volcanoes. It seems these lines separate one moving landmass from another. But could the scientists explain exactly how the landmasses were moving and how earthquakes and volcanoes fit into the picture? They developed a theory, or model as it's called. They imagined that the outer crust of the Earth is like a cracked eggshell, broken into different plates. These plates, they imagine, to be moving slowly about up to a few centimeters a year in different directions. And according to the scientists, it's at the boundaries between the plates that we get earthquakes and volcanoes. Let's take a closer look at what they think happens at the plate boundaries. Along some boundaries, it's imagined that the Great Plates are like two conveyor belts moving apart from each other. It's this kind of movement that's thought to be occurring along the boundary that runs from Iceland down through the middle of the Atlantic. It's called the Mid-Atlantic Ridge. Through their investigations, scientists have been able to date the age of the rocks on each side of the boundary. They've discovered that the further away the rocks are, the older they are, and that the age of the rock for a particular distance from the boundary is the same on both sides. This has helped to confirm their model of how the Earth is moving about. They believe that below the Earth's crust, the hot molten rock is rising up in eruptions along the ridge and then spreading out on either side, hardening all the time to form some of the Earth's youngest ground. This is what the hot lava looks like as it erupts underwater. It's what the scientists call pillow lava. A new pillow starts as a red-hot crack appears in the black crust, and from then on, the pillow grows very quickly. Sometimes so much lava erupts that an island is formed rising above sea level. In 1963, near Iceland, the new island of Surtsey rose out of the ocean. There are other volcanic islands along the ridge: the Azores, the Cape Verdes, Ascension, St. Helena, Tristan da Cunha. And Iceland is sitting right on the ridge. Its volcanoes erupt from huge cracks which regularly open up in a line running across the island. In 1973, the town of Heimahe was buried and burned by the lava and ash from a volcano. Cracks often appear in the ground. Steam from underground vents is evidence of the constant volcanic activity. But the Icelanders have experienced it many times. Somehow, life must go on. This volcanic activity has caused Iceland to expand, and the continents either side of the ridge to drift further apart. But this isn't the only kind of movement that's going on. At other boundaries, it's a different story. Here it's imagined that one giant plate rides down and under another. It's the kind of movement that's thought to be happening along the coastline of the Pacific, where there's another of these great boundaries. Here the land under the ocean is moving towards America. When it meets the mainland, it's forced down and under, producing a zone of earthquakes. The rock that's been forced down starts to melt and rises up to erupt in a volcano. This is what happened in 1980 to Mount St. Helens. Masses of rock were blown away in a violent explosion of gas and ash, and the countryside around was devastated. As well as boundaries where there is a down and under movement, it's imagined there's a third kind of boundary, where the giant plates are sliding past each other, but they don't slide as easily as this model suggests. These pictures show a town on the famous San Andreas Fault, where that movement is happening. The town, Coalinga, was hit by an earthquake in 1983 when the plates jerked. When the earthquake happened in Coalinga, the scientists were already monitoring with sensing devices and computers the build-up of the earthquake.
Activities all around, right around there.
If the shocks had looked as though they were going to build up to a very large earthquake, the scientists would have had to advise whether or not to evacuate the town.
And there's the latest one.
Largest about a magnitude, something larger than a 5, probably close to a 6. Things are probably going not too well down there.
But it wasn't too serious. There was a lot of damage, but luckily nobody was killed. Scientists now know a lot about the San Andreas Fault and how and why earthquakes happen here. They're trying to use the theory, the plate model, to help them predict when an earthquake is going to occur there. Along the fault at Parkfield near Coalinga, American scientists are carrying out a lot of research to help them make these predictions. One of the things they do is to measure the movement of the Earth around the fold. This hut on a nearby hilltop holds the latest equipment for sensing Earth movements. The laser beam inside the hut is aimed at various points on the other side of the valley. The beam is then reflected back, and by measuring how long it takes to do this, the scientists can calculate over a period of time if the ground has moved at all. Down on the fault, the scientists are using other instruments of measurement, what they call their creep meters, to check any movement along either side of the fault. Rocks don't slide past each other easily. Huge forces build up until suddenly the plates jerk in an earthquake. And any earth tremors could signal the start of this. So scientists use devices like this seismometer to sense earth tremors. There are about 20 of these planted nearby in the ground. This laboratory is where all the research is gathered together. Information comes from over 400 places along the fold. Every movement of the Earth, even the slightest tremor, is recorded. With all this information, scientists are trying to build up a pattern to help them predict when and where the next really big earthquake will happen along the San Andreas Fault. San Francisco has been rebuilt since the disastrous earthquake in 1906, which flattened it to the ground. The ground here is still dangerous. An earthquake could strike it in the same place again. That's why the scientists hope that their model of how the Earth's plates move will help them find a way of predicting earthquakes, so lives and damage to homes could be spared. But it's not just along the San Andreas Fault that their theories could help save lives. All those other towns and islands and countries near the Earth's plate boundaries, where earthquakes and volcanoes often occur, might benefit from the scientists' investigations and theories.
Take the hands-on science centres in Bristol, Liverpool, London and New York, add film stories from the UK and the USA, mix in some television studio demonstrations,